discuss pulley. What is pulley? It is a circular disc having a block and one axle. This circular disc is made up of wood, plastic, fiber, anything it can be. This is called block, this is called axle. There is a fixed support and this circular disc is a grooved disc. Here in this groove the rope runs. So this pulley is a type of simple machine that we use for various purposes. Pulley we have divided into two categories. One is single fixed pulley and one is single movable pulley. What is the basic difference between a single fixed pulley and single movable pulley? If the axis of rotation or axle of the pulley remain fixed, it do not move up and down along with the load, then we call it a fixed pulley. And when the axis of rotation or axle of the pulley move up and down along with the load, then we call it movable pulley. So let us discuss single fixed pulley and single movable pulley together so that we can understand the difference between them. In a single fixed pulley, here is a load and at this free end of the string, we apply the effort. Now this effort is the force applied by the external body to the string, and the string also apply equal and opposite force on the external agent. So you can say this T and E are action and reaction, and according to Newton's third law, action and reaction are equal and opposite. Same thing is true for load and tension T. So we can write load equal to T for single fixed pulley, effort is also equal to T. So what is the mechanical advantage? This mechanical advantage is load by effort. So T by T, that is equal to 1. Now let us consider the case of single movable pulley. For this single movable pulley, this load is supported by two tensions. So here load equal to 2T. But at this point you are applying effort, which is the tension T. So what is mechanical advantage? It is load by effort, that is 2T by T, and that is equal to 2. So one difference you can find that the mechanical advantage of single fixed pulley is 1, but the mechanical advantage of single movable pulley is 2. We know mechanical advantage greater than 1 means it is a force multiplier, and mechanical advantage is equal to 1 means in this case effort is used. This effort is this pulley is used to change the direction of effort. Now suppose this effort point is moving down through a distance x. Then what distance the load will rise, that will be also equal to x. If distance travelled by effort equal to x, then distance travelled by load is also equal to x. So what is velocity ratio? This is distance travelled by effort by distance travelled by load, that is x by x equal to 1. Let us consider in this case single movable pulley. If the effort point is pulled up through a distance x, then this distance or this length of the rope is supplied by both the segments of the string. So both the segments of the string will be shortened by a distance equal to x by 2. That's why the load will be rising through a distance x by 2. So in this case, if the distance travelled by effort is x, then the distance travelled by load is x by 2. So what is the velocity ratio of a single movable pulley? The velocity ratio is given by distance traveled by effort by distance traveled by load, which is x divided by x by 2, that is equal to 2. So mechanical advantage of single movable pulley is 2, mechanical advantage of single fixed pulley is 1. Velocity ratio of single movable pulley is 2, velocity ratio of single fixed pulley is 1. Now what is the efficiency, percentage efficiency of single fixed pulley? The formula is MA, mechanical advantage, by velocity ratio into 100, that is 1 by 1 into 100, that is 100%. And the efficiency of single movable pulley, if we calculate, again formula is mechanical advantage by velocity ratio into 100. So it is 2 divided by 2 into 100. So again it is 100%. Now in single movable pulley, this is not very convenient to apply the effort in upward direction. So we connect a single fixed pulley with this arrangement, and it is like this. It is connected to a single fixed pulley, and this single fixed pulley, here we apply the effort E. Suppose the pulley is P1, this pulley is P2. Here the pulley P1 is the movable pulley and the pulley P2 is the fixed pulley. So this arrangement is little bit modified just to change the direction of effort, because if we connect a single fixed pulley with the single movable pulley, then the effort can be applied in downward direction, which is convenient. But this connection of this single fixed pulley do not change the mechanical advantage, velocity ratio and efficiency of single movable pulley.